In 1957, the Soviet Union launched Sputnik into orbit. Its tiny beeps filled the silence of space, and the breaking of the silence by those beeps ushered in humanity's conquest of space. One of the products of those beeps was the US's Global Positioning System, which has become ubiquitous with navigation. And while Sputnik was the turning point of humanity's relationship with space, the question must be asked: what was the turning point for GPS? What turned tiny beeps in space into a seemingly omniscient navigation system? The answer is obviously not simple in the slightest, but the turning point in the development of modern-day GPS is the radio signals which GPS uses. These signals are why Americans have shed the days of navigating the complex US highway system with paper maps. These signals are how farmers can plant crops with sub-centimeter precision. These signals are how 20% of Americans in 2019 communicated. These signals were not pioneered by GPS. Instead, in the storied history of GPS, one project, often overlooked by history, yet considered by the father of GPS, Bradford Parkinson, to be the system which, quote,
has also many of the attributes that you now see in GPS, and it's probably never been given its due.
This system bridged the gap between Sputnik and GPS and is the turning point in the story of modern GPS. This system is known as Air Force System 621B. So how did we develop such an innovative system? It was discovered that by measuring a phenomenon known as Doppler shift, satellites such as Sputnik could be used to determine where a person was on Earth, with precision previously unheard of. The Advanced Research Projects Agency stepped in and created the first global navigation system using the principles discovered. They created a satellite constellation known as Transit, which in 1960 led to the launch of the first navigation satellite. By 1968, 36 of these satellites were orbiting the Earth, and they helped increase map accuracy by a factor of 100. Yet, even with this massive innovation, flaws were still evident. Transit was not the end-all be-all. Accurate positioning was nearly impossible when moving, which rendered transit near useless as a system to navigate by, unlike modern-day GPS. To solve this, Dr. Ivan Getting, the president of the Aerospace Corporation, a newly formed Air Force contractor, recognized and had a solution to these flaws. Well, really more of a fantasy. He dreamt of a satellite system with 3D precision and 24/7 service. To bring this fantasy to life, he assigned employees to conduct research into his vision, and by October 1963, after research by the Aerospace Corporation's Philip Diamond, in conjunction with the Space and Missile Systems Organization, the Air Force, through the Aerospace Corporation's work, proposed a system known as System 621B. The innovation in this system was, rather than requiring active back-and-forth communication between the satellites, such as in transit, 621B would only receive data from satellites, yet it would still be able to figure out its location. This new method, known as passive location, was not only necessary for the creation of 621B, but also for modern GPS, as GPS now uses a nearly identical system. However, the report only proposed 621B. No realistic concept was yet to be found. That duty would fall upon two Aerospace Corporation employees, by the name of James Woodford and Hideyoshi Nakamura. They would work, beginning in 1964, to produce a detailed report that developed 12 potential systems that would meet the goal of global navigation. After 2 years of non-stop labor, on the 24th of August, 1966, this report would be presented to members of the Air Force. Of the 12 potential systems, 6 were ruled out due to overloading when handling multiple users, and a further 2 were ruled out due to requiring the creation of new equipment. Of the 4 systems left, the Air Force would choose to pursue the one likely to be the most robust. However, the report also outlined 2 problems. First, that accurate clocks were necessary for reducing the number of satellites. And second, that of the 3 existing radio signals sent by satellites, none would meet the requirements set out in the report.
The Air Force opted to pursue the signal challenge,
which would become so pivotal in modern-day GPS. The reason this challenge is so great is due to a property of radio waves, where, Under the right conditions, the waves can interact in a way that makes it so any data included in the waves is lost. Without data, both 62.1b and modern-day GPS turn from one of the greatest human innovations into a very expensive pile of useless electronics. It would be the discovery of this signal that would finally allow the early discoveries from Sputnik to be properly implemented to create full-fledged GPS. This signal challenge would be conquered in 1970, when a signal structure known as CDMA was pioneered. CDMA allows multiple satellites to broadcast data without the data being mixed into other transmissions, by assigning each satellite a special code. These codes not only immediately allowed 62.1b to become a feasible system, but also would go on to be vital for modern GPS's functioning. With the greatest challenge faced in the development of GPS conquered, 62.1b would pivot from theory to a testable system. So, after extensive trials of equipment, with contributions from companies like Grumman and Boeing, as well as from NASA and the Johns Hopkins Research Lab, initial testing of System 62.1b from mid-1971 to early 1972 would trial 62.1b by using 4 separate radio transmitters acting like satellites, and a Boeing NC-135A with a test receiver, which utilized the recently pioneered CDMA signal. Over the course of the day, 31 test flights were made, with System 62.1b assisting the plane with navigation. These tests found that when navigating with System 62.1b, an error of less than 2.7 feet between the actual location and 62.1b's calculated location was found. When compared to the over 10-meter wide error of transit, 62.1b was the step in the right direction for global navigation, at least according to the Air Force. So that begs the question, why do we have GPS and not 62.1b? At this point, DARPA had already been looking for a replacement for transit, and as such, the Air Force brought on a fresh new colonel, the previously mentioned father of GPS, Bradford Parkinson. Although the proposal of 62.1b as the primary replacement for transit was rejected in 1973 by DARPA, Bradford eventually would lay the basis for GPS by implementing parts from transit, 62.1b, and a similar project from the Navy Research Lab, known as Timation. Eventually, this proposal would be accepted, and the first ever GPS satellite would be launched into orbit on February 14, 1978, carrying a modified version of the CDMA code signal, pioneered by System 62.1b. 5 years later, after the shootdown of Korean Airlines Flight 007, President Ronald Reagan would release fully accurate GPS to the public, allowing the innovation of 62.1b to spread throughout the world. And spread it did. During the Gulf War, GPS would allow tanks blinded by sandstorms to navigate the deserts of the Middle East with ease. And economically, 62.1b has had a massive impact. Precision farming from 2007 to 2010 led to the production of $19.9 billion of crops through its efficiency, powered by GPS at 62.1b. The CDMA code, which was adopted for use in 3G networks, led to a 0.15% growth in GDP per capita during the switch from 2G to 3G.
And as much as it's used for technology, it's an integral part of the human experience. The peace of mind given to parents about their kids' safety is provided by Life 360's GPS tracking, which was only possible through 62.1b.
Ever since the 2022 Russian invasion of Ukraine, GPS has been utilized by Ukraine to continue fighting for its freedom. And in the future, with the inevitable switch to renewables, GPS will help to synchronize our energy grid to prevent blackouts. All of these applications, both present and future, would not be possible without the innovations of 62.1b that turned Sputnik into modern-day GPS. The advent of 62.1b led to a world with more precise navigation. The advent of 62.1b led to the communication that shaped the modern internet. The advent of 62.1b led to Ukraine's ability to continue defending itself from Russia. 62.1b was the turning point in the history of modern GPS, and it continues to shape the world around us to this day.